All right, everyone. How are we doing today? Doing all right, in spite of our weather here. I had not the best time this morning when it was raining really bad. It was not. Oh no. Uh, that's no good. Okay, that's yeah. The hopefully that's not so bad, but that's not for the best. Okay. Yeah. For me, it was mostly getting to the point to where you could only really see about 20 feet in front of your car and nonsense. Hmm? Well, I felt like that's what the other drivers were doing to me was just changing lanes and not really caring what was going on and way over driving the visibility conditions on the road. 'Cause we have a lot of people who spend a lot of money on their sports utility vehicles or their big trucks or whatever, and they think they can just drive normally when the hazard sometimes is losing control of your vehicle if you have a bunch of extra tire wear or you try to move the big heavy thing quickly in conditions where you don't have a lot of tire grip and it slides around. But the other thing is just going too fast for what you can see and react to when the skies are all gray and there's a bunch of moisture kicked up that's reflecting extra light so nobody can see anything. Yeah. Yeah, no, the until we give the AIs the wheel in general, the most important safety feature in the car is having a competent driver. So we'll see. Anyway, today, instead of kibitzing, the plan is to talk about a data object in MATLAB known as structures. Okay. Um, I will do my best to not make this mistake during today's lectures, but I do want to say here at the jump that I might mess up and use the phrase data structure as a generic term meaning a way to organize information using the computer. That is not necessarily the same thing as a specific MATLAB structure, which is the name of this particular type of way to organize data in the computer. But it's one of the issues with choosing generic terms for things like this. So I'll do my best to keep those separate. Okay. Let's start with an example here. We'll get over to MATLAB. And there are a couple of different ways that we can instigate structures in MATLAB. For cell arrays, one of the things that we could do was use the curly braces and then just start typing things in and categorizing information. Okay, so we would construct it like we would construct a matrix or something. For structures, there are a couple different ways to do it. And what I'm going to start with is this. Excuse me. Got out of order here. Okay. Is by assigning a piece of data to a structure. Okay. So the way that this works is that there are two elements here. The elements are separated by the period that I have used. The first is the name of the structure. Okay, so the structure here is named student, and the second element after the period is what is going to be called the field within the structure. Okay, now this is special for a number of reasons. Okay, number one, this is the only type of data object that we have used in MATLAB that uses names as the way to organize the information. Okay, when we did things like cell arrays, if I wanted to do something like, say, look at the second cell in that cell array, what I would need to do is use a number, right? And that number is what indicates to me that I am looking at the second thing that is stored within this data object. Okay? For structure, if I want to look at what this thing looks like, I can type student, which gives me the information about the structure, or student.name, which returns the value of the data that is stored within that field. Okay? Does that make sense? All right. Now, of course, things get more interesting when we add more stuff. Okay, I'll type it like this so it's easier to read. Yes. No. The question was whether there is a limit on the number of fields. The answer is no. So you can have as many fields within your structure as you would like. And just like we had done before, if I type student, it will give me the information that is stored in all of the fields, just printed out like this. But if I want it to return the values in a usable format for me, then you type student.homework and it gives me those values. Make sense? Okay. Another thing that we can do is give, say, exam scores for the student. Works all the same way, right? Okay. Now, where things get interesting is what happens when we want to add more information to our structure. Okay? I'm not restricted to one element of this structure. So what I had previously was a student, and I had a number of fields that was associated with that structure, and I could have information that fit into that first category. I can create a second student and get the information for that student as well. Okay. So if I type now student 2, yeah, what it has done, and I want thank you for asking, is when I add a second student, a second elements to the structure. It fills in with empty matrices all of the unspecified fields until I give information to it. Okay? So if I want this student to have homework scores or exam scores, then I would need to put those things in. The fields are going to remain the same for the whole structure. So I want to make sure that I understand your question correctly. Okay, so if within the same structure, the fields are persistent. Okay, so if I want a new structure with different fields, I would create a new structure that has a different classification for field. Different entries of the field can't have different field lists. Does that answer your question? Okay. Now we have to be careful about this because I need to specify that I'm changing values for the second student if that is indeed what it is I'm doing. Okay. We will, for the purposes of this, say that our second student is not as good as the first. Okay. Sorry, I typed in too big of numbers. Okay, so now if I want to look at the information stored in student 1, I have to type this. Because if I just type student, it gives me the gross information about the structure. It tells me how many elements are in the structure and what the field names are for that structure. All right. So if we want to look at the information for the second student, that's what that looks like. And we can, of course, continue on by adding a third student should we like, right? Well, I mean, there's also a student who may or may not count. We don't know if that one's allowed or not. Anyway. Huh? No, this is the other one. Yeah. There are 3 versions of this joke that work pretty well. You have, huh? That is not the clown. Yeah, no. I mean, there's Daryl, his brother Daryl, and his other brother Daryl. That's I forget what it's a sitcom that's old enough that I don't remember exactly what it is, but it's like a Dick Van Dyke Show reference or something. One of that vintage of sitcoms. And then the other one, of course, at least that I think is funny. Oops, come on. Okay, say it again. Hmm. Yeah. So the question here was if we're building a structure, and for that structure, you only have a single instance of the information stored in that structure, then all that's required is that you type just student, and you will get the actual information that's stored displayed as if you had typed this. You could either type student or student one, it would give you this in both cases. If in like in this structure, I have multiple elements of the structure stored, having different data under the same data structure, then you have to specify the number in order to see what the entries are. So that's how that works. A lot of the time, you may only have one structure, so you can use the shorthand version of it. I just wanted to show an example that has the full set of features for this. I'm sorry, what? Okay, so there are two things that are important to know for the purposes of keeping things organized. So if I look at student 2 and student 3, we see that even though I didn't give the full information for the third student, it has fields present for any of the information that was unassigned. Okay? Now, one of the things that can happen, okay, is that there isn't anything in MATLAB preventing me from entering different types of data, different sized arrays, or just different data types in general, into different fields. So we see here that student 1 and student 2, even though they have the same fields, they don't have data that matches one another. Okay, the data types can change. So all this is a receptacle for information. There aren't any restrictions that prevent you from mixing and matching things. Okay? Okay, I think I was I was trying to remind myself whether or not you could delete a field this way. So that's, but yeah, the issue is that it wanted me to enter a student there. So anyway, I was trying to see if there was a tricky way to delete a field in MATLAB. Typically, you don't want to do that, but I was checking to see if it was possible to do it by mistake, at least that way. Okay. Anyway, basic example of what's going on here. And of course, if I were to, for one of these, make a new entry, oops, I should have given a name. Okay. All right. That field is going to get added to the entire structure, even though obviously for our non-Powerpuff Girl members of the class, that's complete nonsense. Right? Huh? Yeah. Yeah. I wasn't going to type out the whole list. It's too long. Yeah, Blossom, Bubbles, and Buttercup. Yeah. Anyway, I kind of skipped over it because somebody asked a question. Yeah. Yeah. Anyway. Okay. So this is the basic introduction, all right, to structures. The other thing that we can do with structures um, would be I'm struggling with names here. Okay, is that it is possible to put a structure inside of another structure. Okay. Uh, basically, you wouldn't necessarily you refer to it as a substructure to show that there is a relate like a hierarchy in that instance, but there is not a specific thing called a substructure. It's just a structure that's stored within another structure. Some, something like that. So you can do things like put cell arrays inside of other cell arrays. You can put structures inside of cell arrays. You can put cell arrays inside of structures, and you can mix and match as you please. Okay. And the other thing that I wanted to point out is that this is the alternate way for us to refer to or to construct structures. So the way that this thing can be built is that you use the struct command, and the first entry is the field name, and the second entry is the entry in that field. Okay, and so these can be any type of data object in MATLAB. So I kept what I typed in there simple, so just so it was easier to read, but you can build these things as you would like. Yeah, you can go nuts as far as putting it like create a giant untractable hierarchy of structures. Yeah, so what I could have done instead of the way that I typed it out kind of piece by piece here, I'm going to clear the student structure so the thing on the right's about to vanish. That's gone. Okay. Oops. I did it again. Okay. Just make it in one step there. And then this is an experiment. Blossom's grades are that good, so we can use her name. Anyway, And so if you can use that statement to assign all of the values for subsequent elements of the structure using the index to make sure that you're putting that information in a separate entry. All make sense? Okay. Oh, you timed our clock. There's a work order in to hopefully fix that, but it's been getting worse and worse. One of the other. And I teach a class over in Hubbard, and the clock in the classroom that I'm in is almost 5 minutes wrong. So it may be that more than 4 minutes, but there are times where you can look at it and it is 5 minutes fast. It's really unacceptable. I think the company that made the software that runs those clocks might not no longer exist or something. Just part of the issue, huh? Vendors come and go, I guess. Yeah, that, or I mean, who knows how many small companies or small to medium sized companies collapsed due to the last year and a half. Yeah. Yeah, that's, I think a couple of them that have broken get replaced by ones that are stored in a warehouse, not by new models. Yeah, I don't think that this particular issue is related to the supply chain problems, but that is another thing that contributes to stuff is costs skyrocket beyond people's ability to pay them for like 4 weeks, and you start losing money. And if you've got a bad lease on where your storefronts or where your warehouses are, you just gotta fold up the tent and try something else. So what? Oh yeah, you can do all I mean, you can use them with any kind of things that you want. There's something that I want to show before I forget to mention it, because it is related to how we work with these things in general. Okay, so we have our structure that looks like this with these field names. Okay, and one of the things that we need to be able to do is say I have a string that is the name of one of the fields that is in my structure. I need to know how to communicate to MATLAB that I want it to invoke the field associated with the structure that has this name. Okay? So you can imagine being in a circumstance where I'm writing a program and say my user says, give me the information that's stored in this field, right? I have to know how to be able to tell MATLAB syntactically how to answer that question. Okay. It turns out that this is how it's done. Okay. I have a variable. The information stored in that variable is the string that points to the field. Okay. And I put it in parentheses. So dot thing in parentheses means read the value that's stored in this variable and then make the call to the value in the structure. Now, what I've done here is set this up so that I didn't specify which student it was I was talking about. So MATLAB gave me in turn all of the names that showed up in the list, right? Yeah, I deleted all of them for so I could show you the other version of the command without coming up with a completely new example. So yeah, that's the reason that there's only 2 is because I deleted it and just made 2. If I wanted the students to what? Okay, so I'm trying to organize my thoughts so that I can answer your question fully. Okay, so looking at the data for these two students, which are the only ones we're going to worry about right now, the question is, can I make queries of the information that's stored in here, right? For instance, maybe I want to know which students have, like which student has the highest exam average or the highest homework average or something. Is that what you're asking? Okay. So if you wanted to do that, what you would do is you would go through and compute the averages for all the students, and then you could use something like the find command to come up with a list that gives you a list of indices. Does that make sense? Okay. It is possible to do what you're asking. There's a lot of typing involved to set up the demonstration for what you're asking about. The main reason for that is that MATLAB is not a program that is optimized. MATLAB is not a programming language that is optimized for things like database inquiries. If you really care about doing lots of data structuring in this format, you would tend to use some other piece of software. Okay. Now, I'm demonstrating this because there's some important stuff that we want to be able to do that uses this way to organize information, including some internal things for MATLAB that organize data this way. All right. So there are a couple other things that I want to talk about first, but if we have time, I will circle back to answering the kind of question that you're asking here. Okay. And then, yeah, we can also take a look at that. Remind me in about 20 minutes so that I make sure that I have time to answer your question there. Okay. So, all right. So this is what I had put up here before, and because I don't specify a student name, I get MATLAB returning each of these values in turn, right? Now, what I want is to be able to maybe say I ask the question, what is a list of all the names of the students in the class? Right? I need to be able to hold all of that information. Okay? Now, one of the things that you can do is store those things in a cell array. Okay? Or store them. That's not what we want to do. This is where we get into having to do some tricky, weird stuff. Yeah. What I want to do is have one cell, or hold on a second. Yeah, hold on. Maybe let me make sure that I didn't make the thing that I was trying to make in MATLAB is just not communicating in a way that's okay. So we have this, and then I need to give it a name. Yeah, it's being slow now. Okay, so now if I do this, yeah, okay, sorry. This works the way that I intended to make it work. Okay. One of the issues with structures is that if I need to extract all of the information in a structure like this, where we have multiple entries, say I have like this is a student list, right? And I want to know the names for all the students in the class. The way that we have to work with this in MATLAB is by using cell arrays. So as we saw, when I called this command by itself, it gave me multiple answers. It read through that list of things and it returned multiple results. Okay, I can't just store this in a regular array or some kind of regular object. But what MATLAB does let me do is if I type this and say return all those values and store them in a cell array, it will construct an appropriately sized cell array where each cell is the information that's returned, which is useful because I can have character arrays or character strings that are different sizes. If I tried to make it all as a matrix, I'd have to do something else. I'd just get one big long string, which wouldn't be helpful to me. As we saw, that was one of the failed attempts that I had typed a little while ago, which we don't want. But here I can keep the information separate. Okay, so if we wanted to do the kind of thing that you were asking me about, which is do some kind of database query, this is the first step. Okay, the first thing that we have to do is pull the information that we care about outside of the structure, right? The second thing that we would want to do is, oops, run some command like this. The issue is that this thing's in a cell array, so maybe we have to try to do something like this, which isn't easy to do, right? So the answer would be make a loop. What? Oh, okay, which means I have to do the whole thing again. No. Sorry, this is a silly thing where we have to be careful about that. Okay, so It turns out that both of those entries that we have before, if we take the averages of those lists, we get 9 both times somehow. Okay, just a random statistical anomaly. But is this the sort of thing that you meant to ask about? Okay, I don't know. This is one of the versions of the answer to your question. So if information stored in a structure, in order to be able to in order to query information about the structure, we have to do a little bit of extra work in order to extract the information out of that. Okay. Now, we only get into this much trouble if we have data structures that have this kind of form where we're building information databases, right? Here we have a bunch of similar information about several different kinds of students, and if we want to make comparisons across the different students, we have to go through some extra work in order to be able to set that information up in a way that's a usable format, okay? And so it involves extracting the values, storing it in some kind of manipulatable object like a cell array. Cell array is going to be the choice that you make in this instance. And then you have to peel the information out of the cell array from that point and work with it, which isn't difficult. It just requires extra steps, a little bit more typing, and you probably have to write loops because MATLAB's built-in functions don't have the nice vectorization features that would say, take the mean of all of the cells in the cell array, right? That's why I typed the previous version of the command, right, to see whether or not that was going to work, because every few months they change something like that, and things that didn't used to be possible are now possible. So that's one of the things that they haven't made possible yet. Occasionally, yes, they depreciate functions. I think I mentioned earlier when we were doing the numerical integration stuff that they keep changing the name of the integration function and taking away older versions of it. So, because like there used to be a numerical integration routine that was named quad, Q-U-A-D, for quadrature, that no longer exists. Huh? Okay. Well, sometimes you can use it and it'll come up and say this is being depreciated. Don't do this anymore. There are some function evaluation commands that have their syntax change, or they want to move people over to a new version, so they say you can't do these anymore. It may be there, it may be not, but it changes from version to version about whether or not. Yeah, see at the very bottom it says quad will be removed in a future release. All right. Just so those of you online have a visual reference. Okay, mine doesn't say will be removed in a future release. Oh, there we go. Sorry, there it is. Okay. Anyway, so they do take things away. All right. So one last thing that I want to mention before we answer some homework-related questions here is how this shows up in MATLAB in a way that you may interact with it. Oops. I had plot on the brain. I couldn't type anything else there. I'm going to keep this simple. And make a plot here, okay? Wanted to give this a non-standard feature. I realize this is probably fairly hard to see, but it's just a dotted blue line, okay? Made a graph of a parabola. Nothing crazy, okay? What I want to point out is that if you when you invoke your plot command, give a variable name. What MATLAB does is it constructs a function handle that stores the information for the data for this plot. Okay. Now, H is a special built-in structure in MATLAB, or a class technically, all right, but it looks more or less like a structure, and it has a bunch of properties. Okay, so if I wanted to change the color of the line, what I can do is, like I would manipulate a structure, change the variable. And now it has a, I can't even tell what color that is, line. So let's make this easier to see. All right. Yeah, so it's a kind of a forest green color. All right. I was just typing in numbers. I didn't know what I was going to get. All right. The point was that it's not blue anymore. Change to something else. Okay. The other thing, of course, I did in order to make this easier to see was use the line width property in order to make the line thicker. Okay. And we can change all kinds of stuff. You can change the marker size. You can change the marker to some other value. Okay. You can change the X data, Y data, Z data for these things. You can assign a color to the marker. There is no current marker, so there wasn't a need to specify a marker color. This is when the data points have, because MATLAB plots by connecting the dots, right? So it draws line segments between the pieces where it has data. And if you give it a marker, it will put an actual marker on the actual specified data points. So here, this is just a dotted line. So I say, connect the dots, draw a dotted line. But I could also have different line markers as well. But the point is that this thing is set up and evaluated like a structure. So you interact with it the way that you would interact with a structure. And so whenever you see plotting type things, this is one of the things that you could do. Now, these options aren't available to you unless you make this kind of assignment when you invoke the plot. All right. And if you want to see a list of the entire, all the properties that are associated with the plot, you click the list and it will print off all of the rest of this stuff. Okay. Bunch of stuff here you're probably not going to want to mess with. Okay, but they are available. And if you need to read what the different options are for these things, you can go to the MathWorks website and look at the plot command, and it will give you a list of these properties, or at least links to where you can go and read about how some of the more esoteric ones work. Okay, but this is all the stuff that you need in order to use the figure. Now, if I close the figure, I won't be able to manipulate these things anymore because I'll have gotten rid of the stuff that all this points to. So these commands only work while the plots, the figure window is open. Once I close the figure window, I can't do anymore. Yes. Mm-hmm. Did you close the figure window? Okay. Usually, yeah, that sounded like might have accidentally closed the figure window problem. I've done it too. You feel real dumb because then you have to go back, and if you've made manual changes, you have to make them again. But anyway, so that's where I wanted to get to today as far as structures go. All right. The next lesson, in general, relevant to this material, is going to be how structures show up in a much more sophisticated type thing, which is going to be our through thread for the rest of the semester. And that has to do with something in MATLAB called classes. Okay, which are one of the things that we can make if we use our right click create a thing menu. All right. Now, I'm not going to get into this right now because there's a bunch of specific information that has to be, you have to do. Classes are picky. All right. And so what I want to talk about before we get into the idea of creating our own classes are some of the classes that are built into MATLAB and how we interact with those. Okay. And then go through and talk about the basics for this. But just so you have an idea in your mind, that's the direction that we're going. So we're not going to have an assignment that is specific to structures. Okay. I want you to understand how they work because what I really want to talk about is classes. That's a deeper and more interesting set of things to work with. But the syntax that classes use resemble in a lot of ways the syntax for structures. Because what we were looking at with the plot stuff is actually a class. It's not a structure. But the way that it stores information looks like a structure. That's why. Mm-hmm. Yeah. Yeah, when I clicked this, it displayed all the rest of them. Okay. So this is a class because it is a class that is named line and it has these properties. Okay. The difference between classes and structures are purely data objects. Classes have methods. So a class will have specific functions that are designed to only interact with elements of the class, whereas structures are just ways to store data. All right. Now, when you construct a class, you will use something that looks like a structure in order to hold the data for the class. All right. But the difference is that classes have methods. So classes have methods and properties, and the properties of a class are the same thing as a field for a structure. And we'll see all this vocabulary when we get into the thing, because even if you were to make a generic class, and open up the basic version of this that MATLAB gives you, there are properties and there are methods. Okay, so that's how all that goes together. All right. So I was asked to take a look at the code here for this, and to talk about the plotting routine for Simpson's rule. And to kind of set this up in a way that's makes sense to what it is we want to do here. Okay, so if we're doing Simpson's rule and we want to do the plotting, the main tool that we want to use is the area tool. Okay. Just because it gives us a convenient way in order to do the area for each of our regions. But in order to set this up, what I'm going to need is the 3 points that are necessary in order to build the parabola that we care about. Okay. So what I want to do is I'm going to use P and Q here, just so we're not. Actually, hold on. I'll use R and S. I just need different letters so that I don't confuse things that shouldn't be confused. Okay. And I want this to make sure that it has the correct number of elements in it. I think this might go to n-1. If I need to correct it, I will correct it. Okay. So the x values look like this. The r the r values look like this. The s values should be evaluating the function s at each of those entries. Okay, and then I'm going to want this to be a column vector, so I'm going to go ahead and take the transpose of r here so that s gives me a column, because I want to set up a matrix equation. I want to create a Vandermonde matrix for these 3 points. Okay, so we put in the Vandermonde matrix here for r. And what I want to do is I want to build a polynomial that is based on v backslash s, because the linear algebra problem that we're solving looks like v times r equals s. Right? Yeah. That's f of x is basically what I'm writing for the s part. I'm just using not x and y because x and y already mean other stuff. Yeah. Okay, and then this needs to be linspace from xj to xj plus 2 because I want the 2 bounds on my parabola that I'm constructing. And then say 50 points for this. And then after all of this, we should be set up to want to do the area command. So what this should be is the x values are t and the y values are polyval p and t, and I don't know if I need to specify a color for that, so we'll go ahead and do it. Okay, so something like this. Sorry, it was 0 to Simpson true. Oh, okay, that's right. Sorry, going too fast. Incorrect number of inputs for property value pairs. All right, sorry, it's been a little while since I've looked up the syntax for this. Okay, yeah, that's what it is. It's just some of these let you shortcut that, some of these don't. Oops, that's not what I wanted. Okay, so I don't have the rest of the stuff that goes in here, but what this does is it gives us the plot for what all this looks like. Now, the function that I picked was very close to quadratic, which looks like, which is why it looks so smooth like this. Okay. What I'll do is I'll graph a different version of this that has fewer points. Well, what the best way to do this would be to do a different color if the value were negative, right? But you'd have to figure out where the function switches SIG in. I'm not worried about that. I just want to do a basic version of this. I think I told you in the assignment to assume that the function was positive or something, right? But anyway, not a big deal.
My thing it says like line 53 is like missing like it wasn't. It might be just my words.
Okay.
No.
This is to plot the original function. I'm reducing the number of rectangles so it's clear what's going on. Now, for the function we've chosen, it still looks perfect because the function that I chose is something that's still representable pretty easily by quadratics. Okay, I'd have to pick a different function before we get into things that look weirder than this, right? So let's choose a different f. Okay, that one's still too good. Okay, sorry. Yeah, it's just putting things together in the right order. Yeah, area is the easiest one to use because all you have to do is have the points for the polyval computed correctly. Okay. Now it is. I know that the graphs look like perfect every time. Okay. The reason for that is that we have to pick something gross here in order for this to be. No, it's because I can't evaluate log at 0. Or that. Well, I also can't evaluate log at 0. So two mistakes. I fixed one of them. Let's fix the other one. Yeah. And again, these parabolas come really close to the value of the function, all right? But we know that we're not actually graphing the function, right? It's just that each segment that shows up can be easily dealt with using the parabola. And then the other thing that we can do is have a scatter plot that does x and then f of x with red circles or something. They're a little bit hard to see, but they're on there and they're in the right place. Yeah. Okay. For the trapezoid rule, there are two ways to do it. Okay. One would be to use the area command again. Okay. But I think I may have asked you to use the fill command for the trapezoid rule instead. In order to do the trapezoids, the only change that you have to make is the construction for P and Q. Okay. You have these values for your X values, right? And then your Q values are these numbers here. Okay. The only change that you have to make to go from rectangle to trapezoid is make this, instead of the height on the left, the height on the right. I want to make sure that I get this correct. Parenthesis there. Okay. Oh, okay. Sorry, I don't have the proper K defined for this. So we want K to start at 0 and go to N minus 1. Do I even need this to do that? Okay. Other than some indexing thing that you'll have to have for the trapezoid rule, then this is what we this is how you fix this. Okay. and then I guess I got the ordering of the heights in the opposite order. But so this should be +1, and this should just be j. I told you it was a small change. Okay, and then just for specificity's sake, we see that the trapezoid, even though this curve isn't that extreme, we can see that the trapezoids are merely an approximation. Okay. It is most of programming, just like most of mathematics, is spending a lot of time thinking about what to do so that what you actually do is simple. Okay? It is a refinement process. All right? It's just like if you're building something. If you're building a dog house or a table or something like that, okay? The most important thing to do is to prepare, make sure that you have the right materials, and that you plan so that you're not making guesses or making changes to what you're doing in the middle of your work. Because if you cut a board, once the board is cut, it cannot be uncut. So you have to deal with things to make sure that that's not a problem. All right. Now, programming is a little bit more tempting to just kind of jump in there and get your hands dirty, okay, and start trying things. And there isn't anything inherently wrong with just experimenting to get used to what's going on, especially if you're relatively new and just you need hands-on experience to start getting an idea of what happens to these toys when I try to put them together this certain way. Okay, does this work? Does this not work? And what happens if I do this? Okay, and then you see the results of that experiment, and it gives you the opportunity to go back and think about it again and make some changes and figure out what the impact of those changes are. And maybe the changes don't work the way that you think that they should, so it gets you to think more about what it is you've done and how to put stuff together. Okay? Now, yeah. The idea behind, say, the trapezoid rule and doing this other stuff with the Simpsons rule was to give you another task that was, once you really understood how the first one worked, very, very similar to the other task and being able to make the minor changes necessary in order to get that to go. Okay. And the other one is we're creating basically the same effect, but because what we want is more sophisticated, we have to use something that's harder to work with. Okay. So that's part of why I wanted to do the Simpsons rule version of the same exercise, because it's really the same thing. I need an upper bound and then to enclose an area. But getting what that upper bound looks like is a harder thing to do because it's a parabola instead of a straight line. And so making the bounding box for the shape requires more steps. Okay, and then of course, since this one is a little bit harder, we use kind of our niftier area function in order to accomplish this task. Because we know the thing that we care about is the x-axis on the bottom. Okay, we could do these other commands using the area thing too, where basically instead of 0, 0 and these first two elements here, all we need is these two elements, or sorry, the second two elements of each of those vectors. Probably in the other order, because for this we have to draw the box, right? That's why the trapezoid was wrong the first time, because I forgot to switch the order of the top coordinates. Okay, that is our time for today. I hope this was helpful, and what we'll do is come back next week and start talking about classes. We'll start with some examples of things that are built in. We will build together a couple of simple ones that the pieces should be pretty easy to understand, with the idea of working to the last few weeks of the semester to building some that are a little bit more sophisticated and more involved, and call back to some of these mathematical tools that we have previously used and incorporate them in our classes when we have a bigger question to ask that needs little individual pieces to all work together in order to create the last result. All right, take care, enjoy your evening, rest of your week, and I will see you next time.